Okay, folks, we're going to get started. Nando's going to be presenting tonight on a JavaScript game that he built out based off of another game called Left 4K Dead, which is a little zombie top-down shooter game in 4,000 lines of code, or 4,000K, which makes sense. Or just 4K?
Yes.
4K, which is 4,000.
Really good on 4K.
Oh, on a 4K, it's made for a 4K monitor, right. Before we get started though, I'm gonna mention real quick that I'm giving some stuff away for free. If you go to learn.webdriver.io/sweeps, and then enter your email address, at the end of this week, I'm gonna give out 4 prizes, pick 4 people from the list, and give out 1 each, just randomly. So I just want to mention that it's completely free, and then the email address, I'm probably going to throw away the email addresses at the end because I don't want to spam people, but there is a chance, or there is a way that you can sign up for more information about WebDriver IO. But anyway, that is there. Yes?
Just a quick question. Is this Left 4K Dead or whatever, is it going to be available on GitHub?
All of the source.
Okay.
Yeah. So that'll be there. But yeah, that's this. That's all. And then I usually have announcements and stuff, but I don't really have any today because I'm tired. Very tired. So with that, I'm going to hand it over to Nando.
Hey everyone, my name is Nando Pena. I'm an employee at Rackspace, a web developer. And let me give you a little bit of a preface about this talk. I'm kind of still working it out. It's kind of lo-fi. There's this game called Left 4K Dead that I came across like back in 2009. It's a Java game, and I was kind of wanting to learn web development. I'd mostly been doing C#, a little bit of C++, and like for college projects. So yeah, I thought it'd be a good project to convert it over to JavaScript. It was kind of neat, but I looked back at the old code I did and I thought there was a lot of room for improvement. Unfortunately, the game doesn't really work anymore. If you go to it was written, actually let me tell you a little bit more about it real quick. So this game, Left 4K Dead, it's the product of this competition called, it's like, I don't know what it's called, it's like a 4K Java competition where you're supposed to write, they're pretty much all games, write a game or some demo that's in 4K, 4 kilobytes of code. A lot of times that's for minimized, obfuscated, however you want to call it in Java, lines of code. And so this particular submission was the winner of 2009. It was written by at that time, kind of unknown programmer by the name of Marcus Pearson. Who knows who Marcus Pearson is? The guy that wrote Minecraft. So this is before Minecraft. He wrote this Left 4K Dead. It's just a real simple game. Looks like it, would be like a Nintendo game or something. Yeah, so that was his submission. He won, and I tried the game out. I thought it was kind of fun for a quick little game. It's impressive for 4K, but it's not impressive in on its own merits. But the thing is, it was written in Java on a 2009 Java runtime, and it pretty much doesn't work anymore. So all the different places you could find online to try to play it, you can't really play it anymore unless you downgrade your version of Java, and then you can try it out. So I'm just gonna show you a video of the game playing, just so you can get an idea about it. So yeah, just looking at this game, it's pretty simple. You just walk around, you shoot the zombies, you can reload. You got your ammo there. There's how many free clips you have or magazines, your health. You walk around, you shoot zombies. They're always respawning in different areas of the map. There's a bunch of boxes everywhere. One of the boxes is red, and you got to walk into the red box, and it just kind of repeats. There aren't really any levels of difficulty or anything, even though it is kind of a difficult game. But lots of cool stuff going on. Like all of this is generated algorithmically. There's these interesting lighting effect, the way that the light kind of peeks around, it projects out. So I thought it was like a kind of a cool game to try out in terms of porting it over. Some problems, with going from Java to JavaScript, especially back in 2011 is when I tried out this project. Java it performs much better than JavaScript does. Even, with all of Google's and Mozilla's optimizations, they're still like, it's an untyped language, JavaScript, where Java is typed, and Java compiles into bytecode. There's a lot of factors that really give Java a performance advantage. And so on my very first pass, the game was pretty much not really playable because of how bad it performed. So I kind of did a bunch of research and made some tweaks, and I managed to get enough performance out of it to get the game running. So I thought it'd make a pretty good topic to talk about the differences between Java and JavaScript. A lot of people that are kind of new at programming would assume, and reasonably so, that there was a relationship between Java and JavaScript. I don't really want to get into the history of the name, but it really shouldn't have been called JavaScript because it doesn't have really much to do with Java at all. But yeah, it's called JavaScript, and it's a completely different language. It really wasn't intended to do a lot of the things that we use it for today, even though it's been updated since then, to be able to do all those things, thanks to Google, really. But yeah, I don't think when they were writing JavaScript, they ever intended to be running a game like that, even as that game looks like it is fit for like a Nintendo. But anyway, yeah, let's go ahead and dive into the talk, and we'll discuss some of the differences along the way. So once I found out about the game, I was like, cool, this game looks pretty cool. I'm going to try porting it over. First thing I need to do is get a hold of the source code. So I opened up the website, and I grabbed the data that I could find. And it looks, let's see, that's not what I wanted. It looked a little something like this. That's our code. Now, this is not literally the code. I didn't have the code anymore that I started with. That code is long gone. So this is my attempt at minifying it. I got this down to about 9K. There's still a lot of room for reduction. In order for him to have submitted it for that competition, it would have had to have been under 4K. So, imagine this, but even worse is what the code starts out looking like. So I'm like, okay, step one, getting the source code. Let's try something different. We could try unminifying this, and I did, and it gets you nowhere fast because when it's minified, all of the variable names are rewritten to just be as short as they possibly can. You have no context on it. It's not a good starting place. So I thought, okay, well, back to the drawing board. I need to find another place. Turns out Notch had posted the code unminified on his own personal site. So I went ahead and went to that next. So this is what that one looked like. This looks much more like a standard kind of Java app. So it's still very, very sparse. There are no comments in there. There's a lot of very terse naming conventions for the variable names. And here's the thing, writing this style of code where everything's kind of in one big giant function is actually very performant. And whenever you try to split everything up, you lose a lot of that performance because you're making extra lookups for memory addresses and trying to execute the code there instead of just running everything in line. Not to mention the fact that that I'm talking about in the JavaScript world. In the Java world, all of this just gets compiled down to bytecode, and it's really no big deal for it to run efficiently. But we got a big beast here that we have to convert over. And some of these things don't even have equivalents in Java. So I started doing that. I started porting the code over. And honestly, I started this project in 2011, and I had a prototype working, and it was it ran and it worked okay, and it had some optimizations in it, but it really wasn't far from this version of it in terms of understandability. My process was kind of changing things around, running the game, trying to understand what my change did so I could put a comment on what that piece of the code did. I hadn't even really gotten to the point where I was breaking the stuff up. If you want a maintainable code base, you're going to have to do a lot more work than just renaming everything. So I hadn't even gotten to that point yet. So I thought, well, I resurrected this project so I could talk about it, and I didn't want to talk about the piece of junk that it had. So in the last few days, I've actually started back over from scratch. And that's what I'm going to show you. So technically, I'm not going to get that code base. I'm going to, and organize it up. I'm going to get another code base. I found someone else had already done a lot of work in coming up with a better organized version of this code. It's still in Java, and it's pretty much the only other version of this game that I could find anywhere. But this guy got everything busted up into different files. So rather than redo all of that effort on my own, I'm just starting from this space right here. It's still in Java, but we have some actual modules or classes, and a lot of this stuff has already been split up and broken up into with sensible names. So this is a really good jumping off point, and that's where we're going to be starting.
I have a question.
Yeah.
Why did you not star that repo?
Which repo?
It had 0 stars. You said it was great.
This guy? Check it out. I didn't start because I wanted to do it right here for everybody. Boom. I'm gonna, yeah. There, that really doesn't deserve applause. If anything, y'all should be booing me for not starting it to begin with. But yeah, there we go. Yeah, that's true. Yeah, I mean, this is all open source. I'm putting this back out there. I'll, send this dude a link. He hasn't even done anything with it in a long time. But anyway, like this was just an exercise, so I have something to talk about at JavaScript meetup. So where are we now? That let me go back to my commit history. So yeah, like one of the first things you do, I'm not going to open up this commit. I'm renamed all the files from Java to JavaScript. That doesn't win you much. It's not going to do anything at that point. The first big push to get this converted is converting it over into JavaScript. Specifically, I chose to do ECMAScript 6 classes. I didn't do that the first time because I don't even think we had ECMAScript 6 classes back in 2011, but we have them now. And I thought, hey, that'd be a pretty good, closer to an apples to apples comparison, because already you can just look like, hey, look, the class name stayed, the class structure stayed the same. We're still working with classes. Some of the differences, though, in JavaScript, especially in JavaScript classes, there's a lot of differences between a JavaScript class and a Java class. Like Java classes is a true object-oriented programming language. You got public and private scopes. You have inheritance. You have all these different really cool features that you'd expect to have in object-oriented programming languages. In Java, what you really have is you still have a prototypical inheritance model, and you have this syntactical sugar that gets you what is approximately what you'd expect, an OOP class. But it doesn't have public and private. Everything is public. It doesn't even have, you can't even define members. Like, let's just start looking at the code. So here we have, I have some private ints. JavaScript is not typed. There's a caveat to that, but for most of the part, any of the stuff that we're storing in JavaScript is going to be dynamically typed. So we don't have a sense of private or public in JavaScript. We don't have ways to declare what our intent of the variable type is. You don't have the return values that you're going to get for your functions. Everything is very bare bones. Not only that, we're defining all of these here. These are all assumed to be class members on this left side here. These are all class members of the game class. So anywhere inside here, you can just refer to them, and it's implied that that's something that's happening in this class. On the other hand, if you're going to define a class member in JavaScript, you get a constructor function. This has a constructor function as well, but it's going to be called game, and I'm not even sure if this one had a constructor for this particular file.
Is this on? I haven't done too much Java programming. Is this just referring to self?
Right.
Class?
So the JavaScript this refers to the actual class that is going to be created whenever you create a new instance of the game class. So in order to use this, I'd have to type in new game like that, and then I assign that to something, and now I have an instance of my game, and this refers to that instance. Whereas in here, there's like an implied this. Everywhere you see a score or level or any of these variables, it's like, hey, that's going to be referring to its own members. So that's one of the first things we have to do is we have to add this all over the place. So all of the variables that we reference need to have the this applied to them. And so I got that in there. What else do we got? We talked about types. So that this is like the difference of an explicit class reference that we have to define in JavaScript. However, there are some scenarios where we're passing in parameters, not in this particular class, but we should scroll down and find one. Here on getElement, here's another class member class method, and here we get two variables that we're passing in. Well, we don't need to put thises on them because those are not members of this map class. However, the width, on the other hand, that should have had a this. That's something that I missed. So yeah, so any variables that are being passed in, we don't need to have those on the this in the front of it. Same thing with the types here on JavaScript. Anywhere where you're using a variable, you're going to have to define the type. Everything's dynamic over here. JavaScript has one of these idioms where anytime you're referring to, if you want to like expose a variable, you use what's called a getter or a setter. So here we have a real simple function. It's returning an int. It's called getDamage. It's just returning the damage. That's weird that says this. So yeah, like I've kind of just like put this together in a hurry, but it'll be a little more refined as we go. But yeah, so any of the stuff that we're returning, usually the idiom in Java is that you put a getter and a setter there to keep this member private. All of these members were private. That means that you don't expose them to whatever's consuming your class. They can't change them. They can just get them. They become read-only unless you set setter methods to manipulate them, or you manipulate them in other, like here, well, I can't find an example right now, but yeah, here we go. You can reload your gun, and that's going to access all these private members. So it's kind of cool in JavaScript, like we don't really have to worry about all of that extra overhead. We kind of give JavaScript developers a loaded gun and just let them like, hey, there's only public. Anything that you do is going to be exposed. There are ways you can work around that, but you have to work really hard to get around that, to privatize a variable, and it doesn't make the code easier to understand or use. So yeah, everything's just going to be wide out in the open. I don't need to create a getter or setter for my ammo. Just like create the game and use .ammo, and you got access to the ammo. So it leaves things more open for stuff to go wrong, but at the same time, it also reduces the footprint very significantly.
So you don't use getters and setters in Java, you just use them for JavaScript?
The other way around. In Java, the idiom is typically you don't have to, you can have public variables in Java, but typically they'll make the variables private and expose them via a getter, and then they'll use setters if they want to overwrite them or change them. But typically, if you have like a read-only getter, so I can read the variable, and then other things. In the case of this game, like ammo only increases when you do like a shoot, and then the shoot private the shoot public method has access to the private ammo, and it'll manipulate that, or the reload or whatever. The actual thing that's consuming the class can't just say set ammo to 20. It'll do something like pick up weapon or pick up ammo box, and then it's all kind of abstracted out to. It's supposed to like make it easier to manage because you can control everything more tightly. But in JavaScript, it's pretty much the wild, wild west, and you can just like Jim West Desperado it up and do whatever you think you need to do. The next thing is the idea of like the function scopes. So we're gonna in some of this code that I'm porting over. There are a lot of variables outside of the ones that are defined on the method. So here we're looking at this block for the map. And the map only has a couple things. It has a width, a height, and some elements. And that's pretty much all we're interested in. We pass the width and height into the constructor, and we create everything else on the fly. So that's all the map knows about in terms of its own instance, its width and its height. And then it has a bunch of methods that you can get some other things. But sometimes, like if I'm generating a new map, I'm going to use a lot of variables. So typically what you might see is like here you have a var y and a var x, and then this br only exists inside this loop, so I'd have a var br, and on and on and on. And actually these probably should be brought up too. I think I'm going to do that later on. So one of the drawbacks of creating all of your variable names within a loop is the way that garbage handling takes place is that var br, it grabs a spot in memory, and then the loop runs, and when it gets to the end of the loop, that memory spot is released. And then the next time the loop starts back up again, it hits that var again, it's going to get a different spot in memory and save that new calculation. So it's hitting up a bunch of different spots every time you try to, every time you remember this loop. Now, that might not be that big of a deal, but whenever you're talking about trying to run a game in JavaScript, performance is going to kind of be the thing that makes the game work or not. And that was definitely what I ran into. I found that, yeah, I can port it over, but it runs too slow. It's not comparable to the original. So you want to use like every optimization trick you can use. I'm the type of guy that loves pre-optimizing. I always hear that pre-optimizing is bad. I never heard a good explanation for why that is yet, and so I continue to pre-optimize in my day-to-day life. So one pre-optimization we can do is we're going to use an ECMAScript 6 feature called let, which manages the scope of the variable that gets created much better. So it's a little more secure, but also we're going to define all of our variables here in the parent right under generate, the only place where they're pertinent. That way, all of these spaces only are created once, and every time this loop runs through, we just save a new variable in there. We don't have to reallocate memory. So that actually ends up saving you a lot if you're running these calls over and over again. This generate function is only going to happen once at the beginning of the map, but there are other examples all throughout the code where you can see I'm just going to pile up a whole bunch of declarations at the beginning, and they're going to be strewn out all throughout the function, and that's for performance reasons. I think also if you, depending on like if anyone uses linting whenever they write their code, who knows what linting is? So yeah, like if you use linting for your code, they'll recommend you do that anyway. Like for ESLint is the one I use, and they say like, hey, define your variables in a higher level of scope just because it's more performant.
So out of curiosity, how much performance gain do you actually get?
So in that map generate one, you're probably talking maybe 20 milliseconds. It's going to be negligible. But whenever you have literally 350 zombies and you have a triple nested loop trying to calculate the velocity of a bullet and determine which of those 350 zombies you hit, and you don't have anything like a BSP tree to try to like bust them up into smaller chunks, you're gonna try to use every trick you can. And when that's running, thousands of times a second, it's going to make the difference between, maybe 10 frames a second. It might be the case. Now, I haven't done a lot of metrics on this in terms of like actually timing things and seeing how many frames a second, but I basically crawled my way up to a playable frame rate, and I'll show you what we got at the end of the presentation. So we don't need getters and setters. We talked about that. They say not to use plus plus and minus minus, the incrementer and decrementer. I'm not really sure why that is. But here's a little link I found about it that talks about it, and it is somewhat performance related. Instead, I replaced all of those with plus equals and minus equals, which have equal performance to just saying like A equals A plus 1, same thing as A plus equals 1. Somehow that's going to be better than plus plus or minus minus. I know one of the considerations is typically when you have a calculation, a complicated calculation, and you're using an incrementer, it does make a difference if you put it before the variable versus after the variable, and that could lead to problems debugging. But either way, like I'm just kind of taking in some general practices that I've heard that are performance related and following those. Then the last thing is we have a handful of other Java idioms that might not have exact parallels inside JavaScript. So we don't have system out print line or system out or system nano time. I'm just going to use the equivalent. Console log, Windows performance now, these are ways to keep time and ways to log output. I use web performance now. You could also have used date, but performance now, it says it is a higher performance. Now that doesn't typically mean the same kind of performance in the sense that I've been talking about. It's not that using this method is going to be quicker to execute than the other one. What it does mean is that it's going to give me a higher resolution of time. So instead of getting a millisecond range, I might get like a nanosecond range. I'm not sure that's going to make a big difference, but I just went ahead and used it anyway just to see how it worked. This is very much an experiment for me. I'm converting this over, and then I'm going to kind of like log all the differences, play around with it, and try to just like get the best performance out of it. Yes, what's up? Go ahead.
Just real quick, is generate a kind of constructor on one of the previous?
Generate?
Yeah.
I think the question was, is generate a constructor? Generate, I think what you saw was probably the map generate function, and that's just, I created a map class, which is going to hold all of the locations that you can visit. Generate is the method that's going to construct all of the, it throws a bunch of boxes down and colors them pretty much. So we don't have a main equivalent. Here in Java, you're going to have a function called main, and that's going to be the first thing that kicks off. It's in here somewhere. Let me back up here. The main function, it's the application entry point for Java. And here it's going to be in this left4k dead class. Left4k dead is the primary constructor or the primary object of the game. And I don't have the main here yet, but you can see what it looks a little bit like this in Java. So the main is going to be the first thing that the application executes. It's here inside that same left4k class. It's going to create a new instance of itself, assign it. It's going to set some basic stuff about how big is the game going to be. Can we see it right now? This is all using the Java built-in layouts, our standard layouts. So it's going to pick a layout to display it, and then it's going to finally run the game. Now, a lot of this stuff we can do in the actual index.html or in a different script, or I don't have it in here yet because this is kind of a work in progress. I do have a prototype, but it doesn't have all of the advancements that I have that in the code I'm showing you right now. And then what else do we got? There's a bunch of UI events. Those all use Java-specific event handlers that aren't going to exist in JavaScript. Some of those we'll need to replace. They pass around random a lot. I'll mention this briefly, and we'll talk about the random more in depth, because that's going to be where we can get some of the biggest performance gains, surprisingly. In this game, Notch had this idea that you could put in a seed value for the map. A random seed means that I can feed my random number generator this starting point, and then I could predict, I can make the numbers that are generated deterministic, meaning that if I always put in the starting point, I always get the same string of numbers. They're still going to have a random distribution, but they'll always get the same one. So what that allows you to do is you can replay the same level over and over again, because all these things are randomly generated. It takes random numbers and decides where to throw down these blocks that are going to be the rooms, where to throw down the zombies that are going to appear. They're all based on random number generation. So if you're able to seed the value, you can repeat, you can make it deterministic. Go ahead.
I noticed that. So what is the difference when using like the math random function in Java versus the random class that you created?
Yeah, I created a random class. The math random used to suck. And that's part of the talk that I have. They actually, in the very last version of Chrome, Chrome 49, the last stable version, they actually made some significant improvements to math.random. And I didn't have that at the time I started this project, which was not that long ago. So I was just like, math random is very slow. I wonder what alternatives are out there. There's tons of other ways you can generate your own random numbers. I'll even show you one that I might have inside there. Ultimately, I opted for a different technique, which we'll get to pretty soon. We're on step 2, that's in step 4. But yeah, in order to have that seedability and the ability to make all of the game sessions deterministic so you can repeat the same map over and over again, he decided to create an instance of a random number generator, seed it, and then pass that around to the important parts, like the thing that spawns the enemy, the thing that spawns where your bullets go, the map generator. Anywhere else that you're using random number generation doesn't really matter too much. But yeah, those were the important pieces where he used the seeded generator. There are no seeded random number generators in JavaScript, so that obviously we're not going to be able to have that feature without re-implementing it, and I haven't gotten that far to it just yet. Then one of the last things is an idiom in Java. Because Java is a statically typed language, you have to define what data type all of your variables are storing. Anytime that you go from one data type to another data type, if you're doing an operation and you want to store that and it ends up as something different, like say you're multiplying a double with an int, there's a lot of scenarios where you might want to do that. Well, what does it end up as, a double or an int? Well, you have to tell it what it's going to end up at. It's not going to make any assumptions for you. That's the notion of a strict type programming language, where you need to tell it exactly what's going to happen. So a strict typed language would have or it might be like strong typed. I always forget. There's a nuance between a strong typing and strict typing. I think strict means you have to define it, and strong means it doesn't easily get converted into something else. So they are related. So you have this notion of casting things where you'll say like, here's an operation, I'm gonna put in parentheses double to let the compiler know this needs to become a double whenever it's done. So we don't need that anymore. In fact, we can't really do that. Moving on to the next interesting point. So this was like, I spent a lot of time converting all this stuff into ECMAScript 6. And there's just a lot of stuff here. Like almost every single file has 90% of it, has 90% of the content changed. But they're all real little changes, like, you know, adding this, and this has to go in for the local functions as well as the methods. Getting rid of all those idioms that we talked about and replacing them with whatever the closest equivalent is. This is where I spent a lot of time. But that's also where, if you're going to take on a project like this, where having a really smart editor with find replace with, you know, some liberal usage of like reg expressions to make sure you only get the stuff you want comes in very handy. So I probably only spent like maybe 2 hours going through all of this code and rewriting all of this stuff. That gets us to the next step. Okay, now we got all this code. It still doesn't do anything yet. We still can't execute it. We need to like create an application infrastructure for it, link all this stuff up together. So we want like an index page that we can display the app on, and we want it to load all of our files. So there's a lot of different ways you can do that, but I wanted to try out something that I hadn't tried out before. Here we go, add an app entry and build files. So I decided to go with something called Webpack, which is pretty familiar. After I read the documentation on it, it seemed like it was going to be really easy to get Webpack installed on my application. I just brought in that single dependency of Webpack, and here's my main web page, like the index file. So you see it's looking for a bundle.js. Another way you could do this is I could have a bunch of script files for each of the individual JavaScript files that I've created. I need to insert them all inside a very specific order. One of the big differences between having an old school Java object that's based on a function and a more recent ECMAScript 6 class, which is effectively just a Java function object, the class does not do something called hoisting. Who knows what hoisting is? Hoisting is this concept where you lay out all of your functions, and they have to be, and if they're not, if you declare them and they support hoisting, then the declaration gets moved to the top of the scope. So at any point inside the code, you can refer to that, and the scope is going to understand what you're talking about. So a real simple example is if I have, you know, a hello world and I have a function that says, you know, print hello, if I don't have hoisting and I tell it, here's my print hello, and then right above that is the execute the print hello function. If it can't hoist, it's going to say that this thing hasn't been defined yet. It needs to like execute in order of, first I need to define the function, then I can execute the hello function. So hoisting, I consider it a feature. A lot of people don't like it. It can be problematic, but I think if you use it intelligently and you know what's happening and you understand the concept of hoisting, it's a feature. It's not a bug or anything. So there's no problem with hoisting. But ECMAScript 6 doesn't let you hoist. So you have to make sure that you put everything there in the proper order. Otherwise, you're going to get errors about it, can't find the function trying to execute. I decided to just sidestep that entire whole thing, and I heard about this technology called web components, which is supposed to be the latest and greatest standard. It's kind of slow adopting, but a web component is this idea that you can encapsulate your HTML, your style sheets, and your JavaScript into these like modular pieces or these modular, they're modules. And then you can import those all over the place. And it's basically an import, a module system, something that Java has been lacking for some time. You might have heard of ASM, or not, what is it called? ADM, AMD? Well, there's a handful of them. There's like the common JS version of it. Like Node.js has like a version of doing exports and creating modules. But yeah, they defined this one for CommonJS that was supposed to, it'd be part of the web component standard. where you can package up your web components and you can just import them in your HTML or in your other JavaScript files. Problem is that it's not supported in any browser right now. I don't even think, like I think maybe through a polyfill you can do it, but that's one of the reasons why I decided to go Webpack, because I heard that Webpack would give you that ability that you could use this this coming standard. You can use it right now via polyfills. So that's like a really long-winded explanation for why I decided to use Webpack. Webpack will look through all of our files, and it will, so it starts off with the entry point. Here it's left4kdead.js, and it's going to look through that to see all of the different modules that are involved that are linked to that, and package them all up in a single bundle, and the bundle is the only thing I care about. It has all of my code in the one bundle. So let me show you what that looks like. Here in my app, we've got all of our JavaScript files inside a single directory now. Here's the left4kdead main file. So these are what these import statements look like. I'm telling it I want to import this object from this module. The module is just a reference to the name of, you can just put like a .js, and that's pretty much what it's talking about. In the same directory, game.js, map, monster. I'm pulling all of these things in. In order for it to be recognized as a module, you just have some object that you're interested in, and you, at the somewhere inside the code, you tell it you want to export that. This doesn't have an export because this isn't consumed by anything else, but game is consumed. That was the first one we had. So game at the very bottom has this export default game. So that is the line of code that right now Webpack needs, and in the future any browser that supports this import syntax, they need to know what you're exporting to make this a module, and then anyone else can import that inside any other class or any other module. So it makes it real simple to just stitch all these things together. It's the equivalent of what you already have in your Java. So that was kind of the next phase of this. Was I needed to add all these import statements, use Webpack, reorganize everything, hook my bundle up, and then add all the imports and exports. So the last part of that step, and this step is a lot quicker than the last one. There's much less stuff to do. Let's go back to my commits to find that. So add app in build file. So we go add the modules and the exports. So I'm going through, and these are the commented out. That's the equivalent in Java, the things that are getting imported. And here I export the game. I'm bringing in these imports instead of the Java one. So this is pretty simple, pretty straightforward. Along the way, there's a bunch of little things I missed, and then I caught them in later, and I decided to just make the tweak and put it in. So here's like a new Boolean. It's a Boolean is typically thought of as a primitive type, but here it's being used as a class type, and we don't really have that in JavaScript. So I just, hey, it's a Boolean, it's false. You should skip, it's false. So there's a couple little things that I missed along the way. But yeah, this step is real straightforward. Some of these things I haven't quite got replacements for yet. Here we have this data buffer being casted, and then this image class which has a get raster. An image is a Java class that was being imported. It wasn't included in the code. It's like a standard library member, and I need to replace that with something else. Probably going to be Canvas. In my prototype, I use Canvas. So that one's real straightforward. The next step after step 3 is we can start talking about those random numbers. So everywhere inside there, we have the random number class that was used in Java, and it has a lot of things different. It doesn't share many similarities with the JavaScript version of it, so it needed there was a lot of work that needed to be done. Here we got random, nextant. So on most of these classes, they're creating an instance of random. You can't see it. It's going to be somewhere in here. They're creating an instance of random, and then it's being shared throughout this class and then just used everywhere that they need to generate a random number. I noticed some things, though, as I was porting all of this over. Every single case where we're using a random, we're generating an integer. So there's a random. That's one that's being passed around. That's what I was telling you about, being able to make the game deterministic by having repeatable seeded randoms. So here we're like using an extent. Every single random is going to be an extent. All of them, like, I don't know, I need to point them all out individually. But here's where we get a lot of room for performance improvements. Because the JavaScript math.random, it only does one thing. It gives you a number between 0 and 1. It gives you a floating point number. We're only using integers here. So every single time that I need to make a random call, I'm going to have to take a 0 through 1, multiply it by some integer, and then round it off or truncate it or floor it or something like that. And it doesn't sound like a lot, but a lot of these things are happening hundreds of times per frame, and so it adds up really, really quick. So I thought like this is an excellent opportunity for a performance improvement. So the first thing I did was I wrote my own random class to generate the random numbers because I wanted to be able to control how the numbers were truncated or generated or whatever. And I tried a couple different things. Like I started out down here, like, hey, I'm going to take a shot at making a seeded random number generator. So you'll be able to specify a minimum and a maximum and a start off seed. It'll just default to 1. And then I don't want to get into like cryptography, but this is like a real simple kind of way to create a random number. We just pick some numbers that are usually primes or pseudo primes, and you just do some like repetitive math on it, and you try to pick different numbers until you get something that looks like a pretty even distribution. This doesn't really get us too far though, because this modulo operator, it turns out that that's going to eat up a lot of our cycles. A modulo operator is basically division, but you want to get the remainder of it instead of getting the actual, like the main part of it. So it's like the stuff that would eventually become like a decimal place. But it's, if you remember doing your long division, you have that carry thing, and that's going to be like the remainder. Turns out that every time this you use a modulo, it's going to take the number on the left and then the number on the right, and it's going to literally subtract the one on the left from the right every single time, or like over and over and over again until the one on the right is less than here. So the bigger your number is, the less performance you get out of using a modulo operator. It ends up being very costly for large numbers. And to have like a good random number generator, like you're going to be messing with large numbers. So I ended up abandoning this, and I decided to go down a different route. One thing I had learned from some of my computer science classes was, hey, there's another way you can do a modulo, assuming that the number that you're using as your divisor is a power of 2. You can use some bit arithmetic. And I don't, this is another kind of like computer sciencey thing. I just barely understand why this even works. Like, I don't know if I could explain it very well, but we're effectively taking the number and then the number minus 1, and we're like doing a bitwise comparison between them, and what you end up getting is the leftover stuff that would have been the modulo. But it only works for powers of 2. It doesn't work for, it wouldn't work for 37, but it would work for 32. So that's kind of like really limiting. But at the same time, like, as I was looking through this file, I noticed that, hey, like half of these times I'm generating this number, it is going to be a power of 2. 8, 64, 16. There's a 2, there's some 4s and some 8s in there. Like a lot of these things are already powers of 2. So I thought, hey, maybe I can actually get some benefit out of this. So what I decided to whip up was, whenever you ask for an integer, if the number's a power of 2, then you'll use the high performance modulo. Otherwise, you'll just use the built-in one and hope for the best. Now, power of 2 is another performance issue. If you're trying to determine if something is a power of 2, where do I have that? Here it is. So that's another bitwise thing you can do. You can take the same thing, and it's actually, hold up. What did I do? Yeah, it looks really similar to the high performance modulo because it's kind of based on the same concept, and you just determine if that bit part is equal to 0, then the thing is a power of 2. So I'm going to gloss over that, but trust me.
Is that a jitter?
Huh?
Is that a
What was that again?
Is that a jitter, or is that just returning Boolean right there on the is power of 2?
Is power 2? Yeah, it's doing this operation. It's a double equal, so it's a comparison operation. it's saying, if this thing on the left equals 0, then whatever number was passed in is a power of 2. It's basically like doing the high performance modulo, and it turns out that if you do that on a power of 2, it's going to equal 0. So that's the way you can check it, and then we can do the modulo as well.
Put a return type on
Not,
JavaScript?
yeah, not in JavaScript. The question was, do you need to include return types? And not in JavaScript. Everything is dynamically typed. So the operation happens first, and then JavaScript figures out what the result is. It stuffs it into a number, or it's pretty much going to be a number, because they have like a numerical class for almost everything that's a number, and returns that. So this will be a Boolean. I'm sorry, because it's a comparison. This will return an actual number. And so the way that the number system works is if the things that you're working with are rounded numbers without decimal points, then the result is also without decimal points, then the answer will not show the decimal points. But as soon as you introduce one thing in there with decimal points, it converts everything into floats. But they're all technically of the class number.
Curious, why did you not use division
Why did I not use division?
for calculating one?
Because I would have, because under the hood, if I divided, I could have used division, but I would have had to it was going to give me a floating point result, and I really, the whole purpose of this, I guess I probably need a little more explanation about how this random number generator is working. So I'll get to that in just a second. So I had this bright idea, hey, wouldn't it be cool if I could offset all of my calculation ahead of time and then just consume a big dictionary or a big array of random numbers? That'd be really fast. I just run it one time. I don't have to worry about garbage collection that much, and I can just consume all of my stuff as I need it. I didn't want to use an array because every time you manipulate the size of an array, push or pop it, then it's going to do extra garbage handling and create new arrays and everything, because an array is, you can't modify an array, you can just create a new array. So I decided to create a really big array ahead of time, and then I just tracked a position of where I was. So imagine a big array, it has a whole bunch of random numbers already generated for me, and whenever I say next int, it just pops out the next number for me. And then I have a random number I can do some stuff with. Yeah?
So back in the day, I was on a speedrunners forum, and SNES and NES games, they used to just hard code a couple hundred numbers.
Yeah.
And then they would use what the time is in the game, or how much health you have, or some gold or experience, and then they would just do math to that.
Right.
Based on that input.
So the people watching the stream, his point was that this is an old technique, old game developers would use pre-populated arrays of numbers, and then they would just figure out a pseudo-random way to get one of those elements based on time or something like that. Pretty much the same stuff, it's the same stuff I'm doing. I took one extra step though. I found out that there's this cool crypto class, and it has a get random number, get random values, which will generate a whole bunch of random values that are cryptographically safe. That's not too important to me, but I did like the fact that it would spit out a whole bunch of numbers for me, and I didn't have to create another loop.
Is the max value is 2 million or whatever?
The max values for which one?
For what you can have in 8-bit.
Oh, the size of the array, or the size of any number?
Yeah, the size of the number, is that whatever 8 bits?
Oh, yeah, I'm not sure. I think it's a 32-bit number, but it's also a float. So, that's the kind of stuff I really wanted to avoid, getting into the nitty-gritty of what types of number. I kind of approached this with this attitude that if I'm using JavaScript's number class, then I'm already losing performance-wise, because it's a dynamically typed, thing that's just is going to do coercion and all this other stuff that I really don't care about. I just want some raw, fast numbers. I found out that I'd said earlier that JavaScript doesn't really have typing. That's not entirely accurate. It's a simplification. But what we do have is you can create an array where each member of the array is of a specific type. Here I'm creating an array of unsigned 8-bit integers. So this is going to produce a value between 0 and 255. I'm setting max values here as 5,000. So this is 5,000 empty spaces where I can pop in a 0 to 255 number. And then you pass that to crypto.getRandomValues, which is kind of a weird name considering it populates them. It doesn't give you them. It accepts an array, and then it spits out, it puts in each of those places a random number that meets the criteria of whatever the type is. So if I'd have told this to be an int, a 32-bit int, then get random values would have produced 32-bit random numbers. Here I'm using 8-bit, so 0 to 255. Yeah, so this guy's like, this gives me 5,000 random numbers. I'm setting a position, so I don't have to manipulate the array any. And whenever you want a random number, a next int, then you just ask for the next value from this class. That's just going to say, let me take my current position and spit out that value that's already been generated. They're all being stored in values. And then let me increment the position, so the next time you ask, I'll get the next one. And if I'm at the threshold, then I'm going to do a buffer swap. This is another weird little trick. I didn't want to like run out of numbers and kind of like hit the edge, and then JavaScript has to go, let me get the next batch of 5,000 numbers for you, and like have a little hiccup. So in my constructor, I set an interval every 100 milliseconds, and that's a number I'll probably play around with, check the threshold, and that's going to say like how many numbers have we already got. And if we're getting pretty close to the threshold, which is 80%, if I've used up all of the 80% of the numbers, I'm going to start in the background generating the next set of 5,000 numbers. So I have like a big buffer of numbers to work with. And then whenever I run out of those numbers, when I do this next value, it just swaps over to that, where's that next value? Next value, whenever it does that buffer swap, it's just saying, hey, you're pointed at this old version of numbers, now point at the new one, and then this old one will take the place of it and eventually get repopulated once the threshold. This is like a lot of like gymnastics I'm doing just to try to get some high performance numbers. So, but the idea was, I noticed that inside my code, all of the randoms that I were using, almost all of them were either powers of 2 or they were less than 256 in value. Like it wanted an int between 0 and a number less than 256. So I generated a bunch of 256 bit or 8-bit random numbers, and I'm just moduloing them with the number that I actually want. So if I want a random number between 1 and 7, then I modulo that with my random number that's up to 256, and it's going to spit out a number between 0 and 7. So it's like a really clever, well, maybe not so clever, but it's a fast performance way to take a big set of random numbers that are 8-bit and convert them down to the interval that I'm interested in without having to waste a bunch of cycles. So that's like, yeah, that's pretty much that's not even the gist. It's like in detail what this big random number thing is. The only extra bit of interesting thing here is I have a singleton pattern that I'm applying, so I only have to create the random number generator once. Who knows what a singleton pattern is? A lot of y'all do, but I'll go ahead and mention it again. So singleton pattern is the idea that my class, typically you'll have to create an instance of the class, and then you can consume that instance to do your stuff. So here I'm creating an instance of a random number generator, and then I can get those values that it's generating. But if I have like 6 different files, and they can't all share the same random number generator without me passing it around everywhere and adding some extra layer of complexity. So I just wanted, no matter which class you're in, when you ask for the random number generator, you get the same one. So I have a little pattern here. A symbol is another ECMAScript 6 thing, which I don't fully understand. I do understand that it generates a distinct property of sorts. Like it's almost like a random number generator, but I guess it's a lot more in common with a global unique ID of sorts. And so I create a global unique ID the very first time that this class is created, and I store that as my instance. Then whenever you're constructing it, you have to pass in the same, oh, this is an error. That's supposed to say instance, and that's supposed to say instance symbol. Yeah, I copied this pattern, obviously. Here's a little tip. Most of the stuff that I'm doing, I copied from someone else smarter than me. Like, you're probably looking at this, and I might be giving myself too much credit going, wow, this is some crazy stuff. Like, I didn't do any of this. Like, I was not the pioneer on any of these techniques. Like, I just did research. I found, like, here's the problem I want to solve. How did other people solve it? Stack Overflow. Like, this is pretty much like 90% Stack Overflow code that's been copied and pasted, artisanally crafted Stack Overflow into my distinct purpose. But yeah, the singleton pattern is the same thing where you use a static member, which means static means that you don't have to create an instance of the class to use it, but it doesn't get to know about any of the instance stuff is the drawback. So I don't really need to know about it. I just need to know about this guy right here. So the way that this random is intended to be used is you say random.instance. And this is a getter. This is an ECMAScript 6 getter. So even though it looks like a function, you'll notice none of the other functions have this preface in front of it. Static means that I can call it without having to create an instance. Get means that I can use it as a attribute or a property instead of as a function. So I don't have to say random.instance with the parentheses. I can just say random.instance, and it looks it up like as if it were a property of the class. But that's going to execute this function, and it's going to say, hey, if I don't already have this instance associated with this class, then create a new one and pass in the instance. Otherwise, pass out the one that I've already created. And then the constructor says, I need specifically to get this thing. If I don't get this thing, then I'm just going to throw a fit, and I'm not going to make anything. So you can't use new to create a new instance of this random. You have to use this instance method, because otherwise you have no access to this special symbol that it's looking for. So that's just like a real simple singleton method that lets me create the random number generator one time and not have to worry about it again. Now here's a quiz time, pop quiz. What is one really, really good reason for me not to want to create a new instance of the random number generator for every file that I'm going to be using it in?
Because it can mess the file up, right?
No, it's going to perform the same way in terms of the quality of the numbers it pops out. It's going to be a different reason. Anyone else have any ideas?
You're resetting your seed value.
I don't actually have a seed value in this particular instance, so I'm not resetting the seed value. One more try.
Every time you instantiate it, it'll generate another property.
Bingo. Every time I instantiate another member of this class, I'm going to get 5,000 random numbers. And I don't need every single class having its own access to its own 5,000. Why not all just share the one 5,000? That's plenty for everybody. I have a whole system here that's kind of like revolving around the idea that I want to share these numbers to save memory. Well, in this case, I'm making I'm taking up a little extra memory to gain performance, but I don't want to take up memory unnecessarily. So here's the thing, guys. I don't even know how well this works. Like, it generates numbers. It seems to be faster. But I've learned that you can't really trust profiling tools. So I still got like a ways to go to see if this thing is actually worth all the space it takes up. But I don't have to do math.floor, which can be really, really bad. But here's the thing, like, as I was developing this, I kind of like had the realization, hey, if I limit the scope of all the numbers I'm generating to 256 or to 8-bit, then worst case scenario when I'm doing my divisors, I might get like 10 a loop of like 10 subtracts when I do the modulo. So it might not actually be that bad now that I've kind of put constraints on what type of numbers I'm generating. So that's like the other big part of this talk is just talking about all this random number stuff. So the last part, there's still a handful of places inside the code base where I have this Java style array syntax. We'll see what that looks like here. New array width times height. It's going to take the width times the height, and then it's going to create an empty array that has that many spots inside it. Well, yeah, we already talked about these typed arrays. They're really great, and they're exactly what I need in this particular use case. I could just create a new regular array, but these typed arrays have better performance, so I might as well just use them. Turns out, under the hood, if you do nothing but store integers inside a typical JavaScript array, like new array, or you can even just go, var a equals that, you get an array. It turns out that if you just start popping variables in there and you put nothing but stuff that is approximately the same type, like ints, you're going to get some pretty good performance out of it anyway. It's as soon as you If you try to use it as an object with an object accessor method, like this is technically valid JavaScript. I can say, A equals that, and var A equals this empty array, and then I can access it like with a string, and I can technically store something there in that string as well, because under the hood they're all just objects, and JavaScript just like it applies particular patterns based on the way it thinks you're using the object. So there's a bunch of goofy stuff you can do, but what it ultimately does is it costs you performance. So and not only that, like I said before, you can't modify arrays. So I could create this array with the new syntax, new array, and that would be pretty good. And I just put the kind of ints that I want inside there, the kind of types I want inside there, and I'd probably get the good performance. But this way, I kind of got it locked down, and it expresses explicit intent of how this is supposed to be used. So elements, it turns out it's storing pixel values. So one thing that's like one of the only other places where I needed something above above an 8-bit integer was storing colors. So colors are the RGB colors. That's 24 bits typically, because it's 0 through 255 three times, so it's 888, it's 24 bits. They don't have an int 24, so I just use an int 32. So it's a little wasteful, arguably, but probably not really, because there's no alternative. So it's as efficient as it can be. And yeah, so the other thing is I have this unsigned int 8 clamped array. The benefit of a clamped array is that if you try to store a number in there that's larger than the value you want to store, it's going to scale it down instead of throwing an error. I just threw that in there to see how it worked. It's probably more efficient to just use an unsigned 8-bit array instead of clamping it. I don't know. I don't have any metrics to base that on. But yeah, so this is as far as I got in terms of doing the conversion. There's still a handful of things that need to happen, namely with setting up the canvas, and then we're doing all these calculations to throw all these numbers into all these arrays. The last step would be taking those arrays that are populated and then actually displaying them to the screen so you can see what everything looks like and actually play the game. And so that's the next step. And then the final step is rewriting all of the event handling, so I can add in the Java event handlers to get the mouse and keyboard, because right now they're all using names for Java instead of JavaScript, and that of course doesn't work. But I feel really bad if I showed up here and talked a whole lot about this dumb project and didn't have anything to show. So what I can show you is my first attempt, my early prototype, where it does actually work. It's not perfect, and you can see that the code is nowhere near organized. This is the bare minimum kind of efforts needed to convert that old code into JavaScript, and it works, and it performs fast enough that you could actually play it. I got some interesting, I'm just using the regular random number generator, which kind of tells me that it's probably good enough to do that. I'm applying a floor to it and multiplying it by my number to get the int. I rewrote the set pixel method because it's this way is a little bit faster than using the built-in canvas. Anyway, I've talked about it enough. Let me go ahead and show you what the game looks like now. That is very big. There you go. So here's the actual game in playable format. It's generated all the maps. It does all of the dynamic lighting stuff. And hopefully, there we go, we'll see some zombies. Now, one thing you might notice, I'd be surprised if anyone noticed it because I didn't notice it for like a month. There used to be like a walking animation of the guy swinging his arms when he walks and the zombies swinging their arms. It's not working. He's just kind of like scooching along the ground, just kind of hovering. I have no idea why that is. I haven't been able to debug that yet. But yeah, this is it. Once this is actually, it's been a really kind of fun learning experience, and also, just if you're interested in making games in general, Notch uses all of these, we've just talked about the kind of bare metal stuff on how you write code, how you get objects to store stuff and do it efficiently, hopefully. But we haven't even talked about all of the crazy techniques that that Notch used in order to make this game work. Like, all of this stuff is algorithmically generated. You know, there's no sprite or bitmap that's stored off on the side. It's all done, it's all generated, all in the code there. It's all there. It's very interesting to try to like understand how everything works. Typically, the way you do that is you just you either analyze the code and try to make sense of it mathematically, or you just change numbers around and try to see what the effect is. And that's what got me this far, is just playing with all of the numbers to see how they affected the game. Because not all these calculations worked whenever you started changing the types and everything. Some of these calculations would fail or produce really weird side effects. There's one that I kind of recall. I was going to see if I could change it real quick to just give you an example of what I'm talking about.
So as you kill more people, does it like spawn more people?
Yeah, there's always 350. Well, you kill things, and then it once you get past a certain threshold, it'll kind of do a random check to say, like, the closer you get to this threshold, the more likely it is I'm going to spawn more enemies. Anyone have any questions for me at this point?
What's a 170 drift while
Oh, that's how many zombies I've killed. Yeah, so the other thing is, yeah, like the game, once you die, it just freezes. It's supposed to restart, but that doesn't work either. What's up?
Yeah, why would you kite zombies against a wall when you're already in an open space?
Working with a trackpad here. I don't have a. I really have. Like, I need like a mouse and keyboard or a joystick to really.
For real though, can you show me where you look up all the canvas?
Yeah, sure.
Conditioning stuff, because like to me, canvas is like the most. It's not a very nice API for like putting things inside of a canvas. Like it's like, oh, here's my XY coordinates for literally everything I'm dealing with. Is that what
Right.
you're saying?
So the question was, can you talk a little more about the Canvas system, how that works for getting the actual game onto the screen? So for performance considerations, I have the 240 by 240 canvas, and here you can see that's the canvas definition down there in the bottom. It's called buffer though, because that's not the actual one that I'm exposing. I'm exposing this other one that's bigger, 960 by 960, because I don't want it to be tiny. Like, 240, like, that's not a lot of space. Back in the Motorola fat phone days, you had like a 240 screen, and it's not a lot to work with. So it'd be very small if you tried to like play the game off of that size. So I just wanted to make it bigger. But at the same time, I don't want to do calculations for 960 by 960. So I decided to create the image at a smaller size and then use the built-in API to scale it up and display it scaled. So the pertinent pieces of code for that. So this get pixel and set pixel, these are going to be used just to like, imagine it's a flip show, like it's like a flip animation where I'm generating a thing, and then like I'm getting rid of that and generating the next one. I think everyone knows how animation works, but I'm painting all of these pictures, one picture at a time, one pixel at a time, and then once it's completely painted, I show it to the canvas, and then move on to the next one. I don't want to show it in real time as I'm painting it, because then you might get like tear issues, even though it might look like it performs a little better. Honestly, I'm not even sure you could do it that way with the limited API that you're given. You're kind of only allowed to create an image in a buffer and then send the whole buffer to the screen. So that wouldn't really even work anyway. But yeah, so these are just related to creating the image I'm going to display. Yeah?
So a couple of years ago, my friend, he messed around with HTML5. Apparently it's supposed to bring performance improvements to gaming. Do you have anything to share on that?
Not really. I guess the question was about performance. Are there any new features coming to HTML5? Or I think most of those are going to be on a per browser basis. I don't know. I don't really know if the W3.
I think Canvas is HTML5.
Yeah, Canvas is HTML5 in terms of the interface of how you get stuff to the screen. But in terms of like implementation and performance considerations, I think they just say whenever you enter this code, it has this effect, but they don't govern how it happens. Like, they don't govern the implementation. So it'd be up to the individual like browsers in order to do that. But there are standards like WebGL that let you tap into hardware rendering, but that's like a whole different animal. The way that the patterns that you use here are going to be completely different than the patterns that you use, you're going to be like creating polygons and texturing them as opposed to, drawing dots to the screen. Yeah?
So can you show the game again? Quick. So because this is all randomly generated, do you see the fuzzy edge where the light ends?
Yeah?
Has that actually been rendered, or can you just undo the fog of war and see the entire map, or do you
Yeah.
not even know what's behind the next corner until you look?
No, you can totally do that. The way that this works is it creates a brightness map and a light map, and those two components combine together to create this radius that's emitted from you. And the brightness map is just like imagine I have like a lantern and it just creates a little circle around me. And then the light map is I have a flashlight and that's projecting along the map. So if you look again, you'll notice that whenever I shine the light in a specific direction, it illuminates only what would be from line of sight of my character. So that's the light map. And then the brightness map is just the circle immediately around me. But it just I'm generating, in the code, there are generated arrays of the same size as the display there, and they just store values about the light levels, and those are just multiplied on top of the colors in order to give it a particular brightness.
Does that mean you're drawing the entire map and then the darkness filter on top of it?
No, it's the entire map exists in memory in the sense that it's just a bunch of boxes with properties, and so we're calculating based on my position which parts of those boxes that we want to draw, and then we're just drawing that stuff. And then we draw on top of that the light map and everything. The light map needs to happen after the map has been put down so it can create those projections.
So you're not drawing and then erasing
No,
shadows.
no.
So it's basically a layer on top of the map.
Yeah, it's 3 layers. It's like the map is kind of a logical entity that just exists as a collection of these different boxes in a 2D space, and then we project on these rectangles on top of it that represent the viewport, and we just say hey, which parts of the map are in this viewport, and that'll let me know which pixel I need to draw to the screen, and then throw the light map on top of that once we know that. So yeah, getting back to the other thing about how do we actually do this, we create our canvas here in our HTML. That's going to be the point where we drop the actual images on. In this case, I create a buffer, which is the one that I use to calculate what the image is going to look like, and then my true canvas, which is the one that is going to do the rendering, and that's going to be the bigger one because it's going to be upscaled. And I put a little cursor style on there, so it looks like I got a badass gun crosshair. And then inside the actual game, after we init all the core values, we're going to create what's called this is just an element. Anyone that's done web development should be familiar with document.getElement. I'm getting it by a particular ID called buffer, and that's just up here. So now I have the DOM object there in memory, but I want to get from that buffer what's called a context. A context is it's another one of those things I don't understand fully well, but effectively it's a canvas that you can paint stuff onto, but not exactly. That's not super accurate. But it is what we're going to use this buffer, this context from the buffer we're going to pass that around so that we know what to draw on. But it has other things too, here we can specify any fonts that we render through the API, the graphics API, the fill style of the font. Those can be defined on the actual context for drawing. And what happens next? So we basically are creating our empty our objects that we're going to use either just to hold those data or to paint the data to. And after we've gone through all the calculations, I think it's at the bottom. We got the game loop, monster AI. Gun AI, hitbox, damage. Here we go. Oh wait, this is what paints the screen red whenever you take damage. And then here's the final thing. By this point, we have done all the calculations we needed to do for that frame of the game. A frame is like the smallest instance of time that we can calculate. So it's like an instant in the game, you know, calculating what has happened, where things are, what types of like interactions are happening, like, you know, someone getting shot or it's taking damage. All that's been calculated and inside the respective variable. So you saw that we used set pixel and the image data to colorize place all the pixels for that frame. Now that we have that collection of pixels, we can use this context, which has it gives us the access to all the drawing API stuff. We're going to use the function. This is a standard function, put image data. It expects to get an array and then a place where you want to start drawing it. It's going to take all that big array of color values and draw it to the context, which is going to create an in-memory image. And then finally, once I have that in-memory image on the buffer is linked to the context. So manipulating the context has an effect on the buffer. So now that everything's on the buffer, I can take my other context, which is the actual canvas, and I can draw the image to that directly. And I just tell it, you know, how I want to scale it and everything. So that's pretty much the big parts of it. Creating the blank, getting the web element, the DOM object, linking that to a context so I have a way to draw to that image. Then using the context to set all the pixel data, and it's like a big array, and you just set color values on it. And then once that's done, because I'm using this buffering technique, I'm scaling that up to the actual final picture that's much bigger. If this guy wasn't display none, you would see that as it's being drawn. But I put it display none, and it turns out that actually, you know, increases performance. So I can draw it real quick to the smaller buffer, and then I just do one fell swoop to get that on the bigger picture. And that's another technique from old school gaming called double buffering. And I get the bonus here of being able to scale it up in this case. Any other questions? All right, that's what I got. Sorry it was kind of dry. I need to work on this presentation a little bit, make it more interesting. But yeah, hopefully everyone learned a little something. So you can get this code if you want to play around with it. I'm hosting it open source under the MIT license. My GitHub username is TheNando, and it's right here under Java 2JS. And that has all of my code. I'll be continuing to update it throughout the week probably.
Is that from South Park?
I used the South Park character generator like 7 years ago and haven't changed it.
That's cool.